Okay, so I originally had this done too, but I was second guessing myself, so I wasn't able to finish it all the way. Now since it's done, I kind of had to finish it. But here you go. So what we're trying to do is watch the video and determine the angular velocity, mass of the plane, and length of the string. We have angular velocity equals change in angle over change in t. So here's my free body diagram, and it's very important the way we drew it because we got a lot of information from the video. We have the plane, which has a force down, which is Fg. We have force of tension, which is on the string, and then we have x, force of x, which is this way, making an angle to find x, which could also be as normal. And then, since this was already able to calculate with us, since it starts at 0 from the middle, we were able to calculate the degree angle at 53 degrees for this angle right here. That's from the video, which we were able to get 37 for this one because this is a 90-degree angle. Minus 53 gives us 37, which comes in handy later. So the video also tells us the 120 frames per second. That equals 120 frames per second. We know that Ft, force tension on the rope, equals 6.45 newtons. And we know the one revolution, we started it on this side, one revolution equals 76 initial frames. Then it goes around and stops at the same place at 226 frames. So final minus initial, we got 150 frames per second per revolution, first one rotation, and then divided it by 120 frames, we got 1.25 seconds. So we got our time. We know these three equations that are very important, and I didn't know if I'm going to use it all, but I kind of stated all of them. So we have omega initial plus alpha times t equals omega final. Omega also equals 2 pi over t. And then since we have time, we'll be able to solve for angular velocity. And then we have the force for sum of forces equals ma, Newton's law. So our first question, it said find angular velocity. So we have w equals 2 pi over t. We have t, so we did 2 pi over 1.25 seconds. So we have velocity to equal 5.03 meters per second. Okay, angular velocity, sorry. Then our second thing was to find the mass. We know the sum of forces equals ma. We know that we have sum of forces, we have Ft and we have Fg. So force of tension, force of gravity equals mass and acceleration. We also know that x equals Fg. Okay. X equals Fg. We don't know what x is, but we know that Fg also equals mh, but we need to find x. So in order for us to proceed there, to find the mass, all we need to do is go over here. So we know that the force of tension equals 6.45 newtons. Okay, we got that this angle right here is 37 because we were given this from the video, if you paid close attention to it. So we did 90 minus 53 equals 37. So we did sine equals x over 6.45. 6.45 newtons sine of 37 equals x. X we got to equal 3.88 newtons. And remember, newtons, kilograms times meters per second squared. So we brought this over here. So now we know that x equals 3.88 newtons. Forgot to put that in there. Equals mass times acceleration, because they equal each other. So we're trying to find this right here now. So 3.88 kilograms per meter second squared divided by 9.81, which is acceleration, meters per second squared cross cancel, and we're left 0.395 kilograms, which will be our mass. But we rounded up, mass equals 0.40 kilograms. Same thing. Okay, now what I did was to try to find the length of the string. So we know it's a circle and we're trying to find the radius. That's the way I look at it. The easiest way that I thought to do it is go back to chapter 6. Centripetal force is the center for the center pointing force on an object in a circle motion. So it's the force sucking into the center. Okay, so the string in this case is the force, which is the force of tension. So we got the centripetal force equals mv squared r. We need r, is what we're trying to find, which is the length. Ft, so we arrange this equation that we have. So it's gonna be r equals mv squared over ft. Okay, so we plugged everything in. So we have, well, this is when we didn't I just plugged it in this way. So it's 6.45 kilograms per meter squared. This is the mass times velocity, which omega and velocity are the same thing, squared over r. When you times r on both sides, this side crosses up. So it's on this side. Then you bring the 6.4 kilograms per meter second squared on this side. The meters per second squared cross out. The second squared cross out. The 1 meter cross out because this is squared. Because that's what we had to do. So the 1 meter crosses out. And then kilograms crosses out. So we're left with 1 meter. And I kind of messed up here, but our radius is going to equal 1.58 meters, which is going to be the length of the string.